Halo guys, welcome back to my channel. Assalamualaikum warahmatullahi wabarakatuh. My name is Rizka Alfiana from Chemistry Study Program, Faculty of Science and Technology, Islamic University State Raden Fatah Palembang. Okay, in this section, I will explain about the phase diagram, the integration of Clapeyron Equation, effect of pressure on the vapor pressure, the phase rule, and the problem of components. Okay, let's do video. The first theory, the phase diagram. Examination of the diagram as a constant pressure indicated by the dashed horizontal line shows the melting point and boiling point of the substance as the intersection of the horizontal line with the solid until liquid and liquid until gas serves. At temperatures as below Tm, the solid is stable. At the points between Tm and Tb, the liquid is stable, while above Tb, the gas is stable. Illustrations such as the diagram convey more information, and for diagram is called a phase diagram or an equilibrium diagram. The phase diagram shows at a glance the properties of the substance: melting point, boiling point, transition points, and triple points. Every point of the phase diagram represents a state of the system, since it describes values of T and P. Okay, I take the example, the phase diagram for water. From the diagram is the phase diagram for water under moderate pressure. The solid until liquid lines lean slightly to the left because volume liquid smaller than volume solid. The triple point is at 0,01 derajat Celsius and 611 Pa. The normal freezing point of water is at 0,0002 derajat Celsius. An increase in pressure decreases the melting point of water. This lower melting point under the pressure exerted by the weight of the scatter through the knife edge of the skate blade is part of reason that ice skating is possible. This effect, together with the heat developed by friction, combine to produce a lubricating layer of liquid water between the ice and the blade. In this connection, it is interesting to note that if the temperature is too low, the skating is not good. Next, the integration of the Clapeyron equation. We know that the Clapeyron equation have the formula is dP per dt equal delta S fusion per delta volume fusion. Then integral P2 P1 dP equal integral T accent M Tm delta H fusion per delta volume fusion dt per T. Then P2 minus P1 equal delta H fusion per delta volume fusion ln T accent M per Tm. Next, ln T accent M per Tm equal ln Tm plus T accent M minus Tm per Tm equal ln 1 plus T accent M minus Tm per Tm. And the last, delta P equal delta H fusion per delta volume fusion delta T per Tm. where delta H fusion and delta volume fusion is independent of T and P. T action M is melting point under P2. Tm is melting point under P1. T action M minus Tm is usually quite small. Delta T is the increase in melting point, corresponding to the increase in pressure delta P, which was solid until liquid equilibrium. Next, condensate phase gas equilibrium. For the equilibrium of a condensate phase, either solid or liquid with vapor, we have dP per dt equal delta solid per delta volume equal delta H per T Vg minus Vg. D ln P per dt equal delta H per RT quadrat. Next, integral P0 until P d ln P equal integral T0 until T delta H per RT quadrat dt. Next, ln P equal minus delta H per R 1 per T minus 1 per T0 equal minus delta H per RT plus delta H per RT0. Ln P equal delta H per RT0 minus delta H per RT. When log 10 P equal delta H per 2,303 RT0 minus delta H per 2,303 RT. Next, the effect of pressure on the vapor pressure. The intersection of surface solid until liquid and liquid until gas corresponds to a temperature and pressure at which solid, liquid, and gas all coexist in equilibrium. The values of T and P at this point are determined by the condition mu solid T and P equal mu liquid T and P and mu liquid T and P equal mu gas T and P. In the preceding discussion of the liquid until vapor equilibrium, it was implicitly assumed that the two phases were under the same pressure. If by some means it is possible to keep the liquid under a pressure and the vapor under the vapor pressure, that the vapor pressure depends on P. Suppose that the liquid is confined in the container shown in the picture. In the picture, in space above the liquid, the vapor is contained together with a foreign gas that isn't soluble in the liquid. The vapor pressure plus the pressure of the foreign gas is P. The total pressure existed on the liquid. Next, the phase rule. The coexistence of two phases in equilibrium implies the condition, which means that the two intensive variables ordinarily needed to describe the state of this relation. Only our intensive variable, either temperature or pressure, is needed to describe the state of the system. The system has one degree of freedom. One is univariant, whereas if only one phase is present, two variables are needed to describe the state, and the system has 2 degrees of freedom, or is bivariant. Is there 3 phases are present? 2 relations exist between temperature and pressure. Thus, the relation determines temperature and pressure completely. No other information is necessary for the description of the state of the system. Such a system is invariant. It has no degrees of freedom. From the table shows the relation between the number of degree of freedom and the number of passes present for a one-component system. The table suggests a rule relating the number of degrees of freedom, F, to the number of passes, P for present, which is the passer rule for a R one-component system. The last, the problem of components. For the example, the system contains the special PCl5, PCl3, PCl2. There are three species present but only two components, because the equilibrium PCl5 phosphorus PCl3 plus Cl2 is established in the system. One can alter the number of moles of any two those chemical individuals arbitrarily. The alteration in the number of moles of the third species is then fixed by the equilibrium condition. Kx equal x Cl3 x Cl2 per x PCl5. Consequently, any two of the species are chemically independent. The third is not. There are only two components. Okay guys, if I have many wrong words from the explanation, I'm so sorry about that. To God, I beg for forgiveness. Akhirul kalam, nun wal kalam yawma yasturun. Wassalamualaikum warahmatullahi wabarakatuh. Don't forget for like, comment, and subscribe, and share my video on your social media. Thank you guys.